Okay, now I see it. Yes. All right. So let's go ahead and start with our last session. Uh, thanks, everyone. This is Eric and I will be presenting device hardware vendors view of attestation. So this is one joint session. Uh, we both at Broad, we have been talking about, we both participate in OCP, and this kind of cross pollination between hardware management group and the security group is good to understand. So if you go to next slide, Eric. Uh, next. So this is our agenda. We will talk. I'll start with talking about some of the security goal, introduce attestation, and then I'll hand it over to Eric, who will cover in depth the SPDM dice and then talk about the challenges. Okay, so there is a galore of specification here that are listed here, and starting with DMTF, SPDM, and Cerberus, which was Microsoft's contribution to OCP, PCIe, USB, TCG, NIST, all of this as the security of devices, components, and platform security in general becoming important. These standards are trying to address pretty much a common set of problems around the identity of a component, attestation, and how you manage the measurement and secure session for communication within platform components. And from specification standpoint, if you look at one way saying, okay, it's great to see a number of standards body working on this, trying to solve this important problem. From a device vendor standpoint, it also poses a challenge, and we'll get into some later, that having this many standards, they're slightly different, but trying to solve the same problem. From a device implementation or somebody who is implementing this, it requires them a significant analysis, as well as if they have to support multiple standards, it introduces unnecessary complexity. And I think that's one of the challenges we'll talk later in depth. So that's the landscape today. Let's go to the next slide. So what are our goals, right? From device standpoint, what we want to do is, if you take a server and in there you look for a device, what you want to do from a security standpoint or security goals standpoint is you want to make sure that device that is in there is its identity is valid. So it's bound to some cryptographically identity that you can verify. Other things you want to do is, once you know what's running is a genuine device, you also want to know whether there's a genuine firmware running on it, because today almost all the devices are doing a number of control and management functions in the firmware, and they're considered to be very important for device operation as well as the platform operation. So you want to make sure that firmware that is running, it could be one or more images, those firmware components running on the device are authenticated before they are run. So that's where device root of trust comes into picture. And then building on those two, what you also want to do is when you have a device that is in the platform, it is currently in some configuration state. Along with that goes the firmware it's running, that you want to bound all together and sign that through a measurement by signing this with device identity, so that you can attest that device and say, okay, not only this device is valid, its cryptographically bound identity is verified, but it's also running the firmware it's supposed to run, and its current state is tied to what it's running, and I have verified that. So those are the goal. This kind of attestation mechanism, and you will see later on in the protocol, that's where a whole challenge response and request response protocol are defined to cover all these different aspects of device attestation. So those are the goals. Let's go to next slide where I'll quickly introduce attestation. So attestation is basically here based on this. It's basically you are presenting an evidence about a device which could be variable based on its state, currently running firmware and configuration. And this is bound cryptographically to the device. And the concept here is you are measuring that so that what you are attesting is that there is no replay, no forgery, or no other attack. And the validity of that is verified. And in order to get to that, the mechanism you typically use is you take all this configuration, firmware, state, and parameters, and you compute a cryptographic hash on it. And there are those measurements are combined together, which provides you a state summary for the device. And then those measurements, you also sign that device specific key. That's where the root of trust comes into picture. So that those measurement and signing those together, it forms the basis which you use for attestation claim for the device. And of course, in the platform, you will have attestation, an agent which will be actually doing this communication with the device and verifying its identity, attesting the device. And that's where all these protocols and mechanisms come into picture. With that, let me hand it over to Eric, who is going to go over specific aspects of a couple of protocol, and we'll talk about challenges from the implementer's point of view. So Eric. Eric, you are on mute.
Thank you very much, Emil. You would think at this point we would have this completely down, given all the video calls we've been in. So thanks, Emil. What I will do is present two examples of attestation protocols that are being used in the industry today. One of which is SPDM, which is the Security Protocol Data Model. It's standardized by DMTF, which is behind many of the management protocols that we use in our servers and other platforms. It's strictly designed to effectively provide identity and attestation services. One of the newer versions of the protocol also allows authentication and cryptography of the channel, but we won't be talking about that today. We'll just concentrate on attestation and device identity. So the key benefits is that it's a certificate-based, or can be a certificate-based authentication. It has a identity that's based in a root of trust. It leverages a number of different proven standards from TLS and USB 3. And it also uses a number of other protocols in the DMTF protocol stack in order to provide a complete solution. An example of this is PLDM, which allows you to validate and update firmware. Okay, so the second protocol that we'll talk about is a contribution by Microsoft to OCP via Project Olympus. It was contributed, I think, a couple years ago. It's also an attestation protocol, but it also deals with remediation, which is when you have a device that's out of profile. You can then go through either firmware update or other mechanisms in order to bring the device up to state. It also has the ability to do session management encryption. So it is also certificate-based. It also uses a number of the things from USB 3's security infrastructure. The identity is based upon the Trusted Computer Group's DICE protocol. So it has the concept of a device identity, and then what they call an alias certificate, which is used for the attestation process. And then finally, it's a complete solution that's in one kind of umbrella. So with DMTF, with the SPDM, you need a number of DMTF protocols to have a complete solution. This was kind of purposely built from the ground up to deal with only these specific problems. So there's less implementation choices, but it's less flexible than what you would have with DMTF. All right, so these are the two protocols that we're going to use just as a basic comparison. Please, everyone, we're not going to go through each of these. But what we'll go through just big picture is you'll see that there's the ability to bring certificates back and forth between the attester and the authenticator. So that's a certificate stack that is rooted in some trust anchor. There's also this concept of a challenge, and this challenge uses some random nonces in order to make sure that the measurement is fresh. The challenge also ensures that the device takes a measurement that Hamel talked about from an attestation perspective, and that measurement can be a number of different pieces. That measurement is then signed and returned back. So as you can see, there's a bunch of different overlap here, but if you go into the details, there's a lot of subtle differences that between the two protocols and other protocols that make implementing it from a device perspective a challenge. So I'll just highlight a couple of the challenges here. The first one is that the certificates and chain formats are slightly different. So if you look at Cerberus has an index model, and DMTF has got a model that has a stack. There are benefits to each of those. The Cerberus one is easier to parse, but has some flexibility. But the DMTF one is somewhat compatible with USB 3 and has both of which are 509 certificate stacks. The other issue is that if you look at the device, if you look at a model number or a serial number or a manufacturer number that you would like to be able to communicate through these chains, unfortunately, they all use different extensions. If you look at an X509 certificate, you can add these extension fields that can be defined, that can contain structured or unstructured data. Both DMTF, Cerberus, TCG, USB 3 all have slightly different ways that this is done. So from a device perspective, what that means is either you need to support the superset of all of these in a single certificate. Now, we're working with a number of the groups to make sure that this is allowed, or you go through and you have build flags for these different pieces. So both of which are undesirable from a device implementation perspective, because you'd like to have, from a security perspective, a very small number of different variables and attack surfaces. The second piece around the certificate chain is that from an SPDM perspective, there's it kind of comes down as a foregone conclusion that the certificates have been provisioned in the device. There's no real guidance as to how this is done. There's a number of different ways this is done in the industry. Cerberus has a model for this. DMTF or TCG has a model for this. Really what it depends, and also some of the cloud operators have different models on what this looks like. So what this does from a implementation perspective, again, there's a number of different choices that you can make. Who owns the root certificate? How is this actually communicated? Once the root certificate chain is there, how is this actually identified? How is this actually validated? Is there a central CA that is owned by customers? There's a number of different pieces in the provisioning piece that make this a challenge. And then the final two things I'll talk about quickly is that the attestation messages are similar, but they're different. There's also very little guidance as to what you measure and how you do the measurements. Cerberus is a little bit more prescriptive because it builds upon the TCG, the PCR, which is the platform control register model that does a hash and extend. But even that, there's some guidance, but not a lot on exactly what needs to be included in some of those measurement chains. Now, as part of the security OCP security group, our attestation spec does provide some of this guidance, but still, there's still ways that this can vary between vendors and implementation. And then the final piece is that right now, there's not a lot of good open source tools to be able to validate your implementation that works from an interoperable perspective. Okay, so I think I've went through and looked at and demonstrated some of the challenges with implementing this. The big thing that we want to do is make sure that we're not advocating creating yet a third attestation spec. We want to work within the current infrastructure. There's a lot of good work in all of these groups, so we want to work within them. One of the things that we've worked with in the attestation spec is we've put a baseline on a minimum set of capabilities. During the DMTF, during the SPDM negotiation, there's a bunch of capabilities of the device, and these would include the cryptographic algorithms that are supported, whether you support measurements, how the PCRs. So what we've done from an OCP perspective, security group, is we've said, okay, here's what we think is a good set of minimum capabilities. So we're doing that. And then finally, what we're going to try to do is standardize some of the certificate work. This is across a number of different groups, TCG and others. So we're going to work to try to get this through. Also, there's been some discussion about making some of the certificates easier to parse and less error prone. So hopefully we can, moving forward, work on that. And I think that's it. If you'd like to have some additional information, I put some basic specs here. There's the attestation spec, which is from the OCP security group. The DICE infrastructure from TCG has a number of good papers out there right now. And then also the contribution from Microsoft, and DMTF has a number of different very good specifications and webinars and talks. If you can go on the web, you can find it. I think that's it, Hemel.
Hey, thanks, Eric. So the one, I see a question that was on the public. So let me go over that question, and Eric, you can answer.
Perfect.
So this is question from Dhaval Kumar, who is asking, does OCP or DMTF have a proposal for identity attestation of devices with no firmware, in parentheses, immutable code only? SPDM appears rather heavyweight to be put into immutable code. Cerberus docs have been listed as draft since a while, so hard to say if there is a simplified version possible.
That is an excellent question. So, so if you look at the TCG group, DICE, they do have the ability for what they call non-mutable code, as in the device only has non-mutable code. And there is a way to shortcut some of the attestation in that case because it's just a freshness piece. But I unfortunately agree with you that the current status of SPDM was designed for higher feature set devices, particularly PCI adapter cards. So the OCP security group, this is one of the areas that we're trying to push through and do a more simplified model. And there has been some discussion with the DMTF on this. We have a track, I believe, on Thursday where we're talking with DMTF on this, and this is one of the pieces that will come up. So the short answer is I don't have a great answer for you right now, but we're working on that in the future.
Thanks, Eric. And I think just to add to what Eric said, on Thursday, please look for the schedule. Eric has a presentation, but there are a number of OCP security group presentation which may be of interest. One of the things we are trying to do here is between hardware management and security, trying to get to these problems and solve them in a fashion that is with a single approach which applies to multiple implementation. Let me see. Kaylee, do we have any more outstanding question on the public?
That was our last question.
Perfect.
Okay, so with that, we can conclude this talk here. Eric, thanks a lot for joining and
Thank you,
presenting.
Hemel.
Uh, and this is the last talk in our hardware management track. So before we close the track, any comments, question in general?
Amal, we did get one more question come in.
Okay, let's
Let me
look at it.
pop it in the chat for you here.
Okay, so here is the question, Eric. I'm going to read it to you.
Thank you.
Is there an ETA for A, a simplified version of certificate, example not X509, B, list of required fields insert?
So it would depend on what actual standard that you're looking for. If you follow the DICE infrastructure, they basically have X509 certificates and they have extensions that are defined. And the certificates are designed to be lightweight, but as there's very few extensions on them, and there is a couple of different pieces there, at least in the public, around doing symmetric authentication for some low function devices. Now, the X509 certificates have done really good job for us over the years, but there are some particular challenges on that, particularly with low function devices. The ANS.1 parser is historically difficult to implement well. So there is some work within OCP. We've talked in the security group. We've talked about this. There was a presentation by Intel if you go to the OCP wiki. But unfortunately, right now, I can't point you to an actual specification as of yet.
Okay, thanks, Eric. I think that covers all the questions. Any other comment on the bridge from anybody? Okay, so thanks again, Eric, for this talk. And in general, I want to thank all the presenter. Today, we had a great full day track and excellent presentations. I also want to thank all the participants. Hopefully, in this hardware management track, we covered a variety of topics and you're able to get to different aspects of hardware management. If you have any feedback, feel free to reach out to us, project co-leads, as well as IC member or conference organizer. And if there are any remaining questions or anything, or any comments, Kaylee, feel free to forward it to us and then we'll address those. Okay, with that concluding remark, let's close the track here. Thanks, everyone.